NEC Section 250.104 mandates that interior metal water piping within the areas served by a separately derived system, or SDS, must be bonded to the grounded conductor of that SDS. The rationale behind this requirement stems from the fact that a separately derived system operates as an independent electrical system, possessing its own dedicated grounding electrode system. There are two recognized methods for establishing this bond. Firstly, a bonding conductor can be run from the metal water piping to the connection point of the grounding electrode conductor on the separately derived system. Secondly, a bonding conductor can be run from the effectively grounded frame of the building, assuming the frame serves as the grounding electrode for the separately derived system, to the metal water piping located within the area served by the separately derived system. It is crucial to understand that the bonding conductors employed in these scenarios must be appropriately sized in accordance with NEC Section 250.66. The notion that bonding the building water line to the building steel at the main service negates the necessity of bonding the interior metal water piping within the area served by the separately derived system is incorrect. The grounding electrode system for the main service and the grounding electrode system for the separately derived system function as distinct and independent entities. Therefore, the interior metal water piping within the area served by the separately derived system must be bonded to the grounded conductor of the separately derived system, as explicitly stipulated by NEC Section 250.104 FIR. To elaborate further on the requirements outlined in NEC Section 250.104 FIR, it's essential to consider the specific context of separately derived systems and their interaction with grounding and bonding principles. A separately derived system, by definition, is an electrical power source that is not directly connected to the main service of a building. Common examples of separately derived systems include generators, transformers, and solar inverters. These systems provide an alternative or supplementary power source, and as such, they require their own independent grounding and bonding infrastructure to ensure electrical safety and prevent potential hazards. The purpose of bonding interior metal water piping to the grounded conductor of the separately derived system is to establish a low impedance path for fault current to return to the source. In the event of a ground fault, where an energized conductor comes into contact with a grounded metal component such as a water pipe, the fault current will flow through the bonding conductor back to the separately derived system's grounded conductor. This flow of fault current will then trip the overcurrent protective device such as a circuit breaker or fuse, interrupting the power supply and preventing electrical shock or fire hazards. Without proper bonding, the fault current may find alternate paths to ground, potentially through individuals or other conductive materials, leading to dangerous electrical shock situations. Furthermore, the absence of bonding can result in the build-up of static electricity on metal water pipes, which can create nuisance shocks or even ignite flammable materials in certain environments. The two acceptable methods for bonding interior metal water piping to the separately derived system, as previously mentioned, offer flexibility in implementation depending on the specific installation configuration. When bonding to the connection point of the grounding electrode conductor on the separately derived system, the bonding conductor should be connected to the point where the grounding electrode conductor is attached to the separately derived system's neutral point or grounding bus. This ensures that the bonding conductor is directly connected to the system's grounding reference. Alternatively, when bonding to the effectively grounded frame of the building frame must be reliably connected to earth through a grounding electrode system. This typically involves connecting the building steel to a ground rod, ground plate, or other approved grounding electrode. In this case, the bonding conductor from the interior metal water piping is connected to the building frame, utilizing the building steel as a grounding pathway. It is important to note that the size of the bonding conductors used for these connections must comply with the requirements of NEC Section 250.66. This section provides specific guidelines for determining the appropriate size of grounding electrode conductors and bonding jumpers based on the size of the service entrance conductors or the rating of the overcurrent protective device. Using undersized bonding conductors can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. The misconception that bonding the building water line to the building steel at the main service eliminates the need for bonding the interior metal water piping within the area served by the separately derived system stems from a misunderstanding of the distinct roles and responsibilities of the main service grounding system and the separately derived system grounding system. The main service grounding system is designed to provide a grounding reference for the entire building electrical system, ensuring that all grounded metal components are connected to earth. This helps to stabilize voltage levels, prevent voltage surges, and provide a path for fault current to flow back to the main service transformer. However, the main service grounding system does not necessarily extend to the separately derived system. The separately derived system, as an independent power source, requires its own grounding electrode system to establish a grounding reference specifically for that system. This is because the voltage potential between the separately derived system and the main service grounding system may not be the same, and relying solely on the main service grounding system may not provide adequate protection for the separately derived system and its associated equipment. Therefore, even if the building water line is bonded to the building steel at the main service, it is still essential to bond the interior metal water piping within the area served by the separately derived system to the grounded conductor of that system. This ensures that both the main service and the separately derived system have their own independent grounding references, providing comprehensive electrical safety for the entire building. In conclusion, NEC Section 250.104 clearly and unambiguously requires that interior metal water piping within the areas served by a separately derived system be bonded to the grounded conductor of that system. This requirement is independent of any bonding that may be present at the main service and is essential for ensuring electrical safety and preventing potential hazards. The two acceptable methods for providing this bonding to the connection point of the grounding electrode conductor on the separately derived system or bonding to the effectively grounded frame of the building, offer flexibility in implementation. However, it is crucial to adhere to the sizing requirements of NEC Section 250.66 to ensure the effectiveness of the grounding system. Ignoring or misinterpreting this code requirement can have serious consequences, potentially leading to electrical shock, fire hazards, and equipment damage. Therefore, it is imperative that electrical inspectors, engineers, and contractors have a thorough understanding of NEC Section 250.104 and its implications for separately derived systems. By following the code and implementing proper bonding practices, we can ensure the safety and reliability of electrical installations in all types of buildings. In addition to the core requirements of NEC Section 250.104, there are several other related considerations that are important for ensuring the overall effectiveness of grounding and bonding in separately derived systems. Firstly, it is essential to ensure that all metal components within the area served by the separately derived system are properly bonded together. This includes not only the interior metal water piping, but also other metal objects such as gas pipes, conduit, and equipment enclosures. Bonding these components together creates a common ground potential, minimizing the risk of voltage differences and preventing electrical shock hazards. Secondly, it is important to maintain the integrity of the grounding and bonding connections throughout the life of the electrical system. Connections should be regularly inspected for corrosion, looseness, or damage, and any deficiencies should be promptly corrected. Poorly maintained grounding and bonding connections can significantly reduce the effectiveness of the grounding system and increase the risk of electrical hazards. Thirdly, it is crucial to coordinate the grounding and bonding system of the separately derived system with the grounding and bonding system of the main service. This involves ensuring that there is a low impedance path for fault current to flow between the two systems, allowing for the rapid tripping of overcurrent protective devices in the event of a ground fault. Coordination can be achieved through the use of appropriately sized bonding jumpers and by following the guidelines outlined in NEC Article 250. Fourthly, it is important to consider the specific characteristics of the separately derived system when designing the grounding and bonding system. For example, if the separately derived system is a generator, it may be necessary to provide additional grounding electrodes to ensure adequate grounding capacity. Similarly, If the separately derived system is a transformer, it may be necessary to bond the transformer enclosure to the grounding electrode system. Fifthly, it is essential to follow the manufacturer's recommendations for grounding and bonding equipment used in the separately derived system. Equipment manufacturers often provide specific instructions for grounding and bonding their products, and these instructions should be carefully followed to ensure proper installation and operation. Sixthly, it is important to document the grounding and bonding system of the separately derived system. This documentation should include a detailed diagram of the grounding and bonding connections, as well as information on the size and type of conductors used. Documentation can be helpful for troubleshooting problems and for ensuring that the grounding and bonding system is properly maintained over time. Seventhly, it is crucial to provide training to personnel who are responsible for installing, maintaining, or inspecting separately derived systems. Training should cover the principles of grounding and bonding, the requirements of NEC Article 250, and the specific procedures for grounding and bonding separately derived systems. Trained personnel are better equipped to identify and correct potential grounding and bonding problems, reducing the risk of electrical hazards. Eighthly, it is important to stay up to date on the latest changes to the National Electrical Code. The NEC is revised every 3 years, and these revisions may include changes to the requirements for grounding and bonding separately derived systems. Staying informed about these changes can help to ensure that electrical installations are in compliance with the latest codes and standards. Ninthly, it is essential to consult with a qualified electrical engineer or electrician when designing or installing a separately derived system. A qualified professional can provide expert guidance on grounding and bonding issues and can help to ensure that the electrical installation is safe and compliant with all applicable codes and standards. Tenthly, it is important to remember that grounding and bonding are not the only safety measures that should be implemented in separately derived systems. Other safety measures, such as ground fault circuit interrupters, arc fault circuit interrupters, and surge protective devices, can also play an important role in protecting people and equipment from electrical hazards. By implementing a comprehensive safety plan that includes grounding, bonding, and other safety measures, we can create a safer and more reliable electrical environment for everyone. Finally, it is important to recognize that the specific requirements for grounding and bonding separately derived systems may vary depending on the jurisdiction. Local codes and regulations may impose additional requirements or may modify the requirements of the National Electrical Code. Therefore, it is essential to consult with the local electrical inspector or building department to determine the specific requirements that apply to the installation of separately derived systems in a particular area. By following these additional considerations, we can further enhance the safety and effectiveness of grounding and bonding in separately derived systems, creating a more reliable and secure electrical infrastructure for all.